Every single morning of your life it has been there. It rose before you were born, and it has risen on every day of all of human history. It warmed the first humans around their fires, and it warms your face today. The sun. It feels eternal, permanent, as certain as anything can possibly be. It seems like the one thing in the universe that will simply always be there. But it won't, because the sun is not eternal. The sun is a star. And stars, every single one of them, are born, they live, and they die. And one day, in the unimaginably distant future, our sun will die too. So here is the question. What will actually happen to the Earth on the day the sun dies? And I promise you, the answer is stranger, slower, and far more beautiful than the fiery explosion you're probably picturing. Because the sun does not die the way most people think. And there's a twist waiting in this story. The Earth's own ending comes long, long before the sun's does. To understand any of this, you first have to understand what the sun actually is. Because it is not a ball of fire. It's not burning the way a campfire burns. The sun is a colossal sphere of gas, so massive and so compressed at its heart that in its core hydrogen atoms are being crushed together and fused into helium. And that fusion releases staggering amounts of energy. That's the light. That's the warmth. That is what a star truly is, a vast, self-sustaining nuclear furnace held together by its own gravity. Our sun has been doing this for about 4.5 billion years, and here's the reassuring part. It's only about halfway through its life. It has roughly 5 billion more years of steady burning ahead of it, so the day the sun dies is almost unthinkably far away. But now comes the twist, and it's an important one, because it's the honest truth that most people never hear. The Earth will become uninhabitable long, long before the sun actually dies, because the sun is very slowly getting brighter and hotter as it ages. Bit by bit, over immense stretches of time, it's warming up, and in about 1 billion years, far sooner than its death, the sun will have grown hot enough to trigger a catastrophe here on Earth. The rising heat will begin to boil away our oceans. Water vapor will fill the sky, trapping even more heat in a runaway spiral. The seas will evaporate. The rivers will vanish, and the Earth will transform into a scorched, dry world where no life as we know it can survive. So life's story here likely ends around 1 billion years from now. The planet will still be here, orbiting quietly, but it will be a dead world, baked and barren long before the sun reaches its own final act. Now let's jump forward, far forward, about 5 billion years from now, to the true beginning of the end. After all this time, the sun finally starts to run out of hydrogen fuel in its core. And when that happens, everything changes. The core, no longer able to push back with the force of fusion, begins to collapse under its own gravity. And as it collapses, it heats up dramatically. That intense new heat ignites a shell of hydrogen around the core, and the outer layers of the sun respond in the most dramatic way imaginable. They begin to swell, and swell, and swell. The sun starts to expand into something monstrous. This is the phase astronomers call a red giant, and red giant is no exaggeration. The sun will balloon outward to perhaps 100 times its current size, or even more. As it expands, its surface cools to a deep glowing red, but it grows so enormous that it becomes over 1,000 times brighter than it is now. And as this swelling red monster grows, it begins to devour its own children. First it swallows the little planet Mercury, engulfing it completely. Then it reaches Venus and consumes that world too. Both planets simply gone, vaporized inside the growing sun. And then it comes for the Earth. And here we reach one of the great dramatic uncertainties in all of astronomy. Because the fate of our planet hangs on a delicate balance. As the sun swells, it's also blowing off huge amounts of its own material into space, losing mass. And as the sun loses mass, its gravitational grip weakens, which causes the surviving planets to slowly drift outward into wider orbits. So there's a race. The sun is expanding outward, trying to reach the Earth, and the Earth is drifting outward, trying to escape. Which one wins? Astronomers still debate it. It's possible that the Earth drifts just far enough to avoid being swallowed. But even if it does escape, there is no happy ending here. Because our planet would be scorched beyond all recognition, baking under a red giant filling half the sky, the Earth's surface would melt into molten rock. Any trace of atmosphere, any last memory of water, gone. Earth would become a glowing, charred, lifeless cinder. And in the other scenario, the sun simply reaches out and engulfs it entirely, and the Earth is vaporized, its atoms swallowed into the outer layers of the dying star. Either way, the world we know ends. Now at this point you might expect the grand finale to be an explosion, a brilliant, violent blast tearing the sun apart. And this is one of the most common misunderstandings about our star, so let's clear it up. The sun will not explode. It is simply not massive enough. The huge violent explosions called supernovas are reserved for stars far bigger than ours. Our sun's death will be something completely different. It will be gentle, almost peaceful. Here's how it actually ends. During the red giant phase, the sun's core gets hot enough to start fusing helium into heavier elements, carbon and oxygen. This gives the sun one last burst of stability, lasting many millions of years. But eventually, the helium runs out too. And our sun does not have enough mass to fuse anything heavier. The furnace at last goes quiet. There is nothing left to burn. And so, without the energy to hold itself up, the sun does something surprisingly delicate. Its outer layers, no longer held tightly, gently drift away into space. Not blasted, not exploded, simply released like a long, slow exhale. These glowing outer layers spread out into a vast, beautiful, expanding shell of colorful gas. Astronomers call this a planetary nebula, and they are among the most breathtaking objects in the entire universe. Shimmering rings and clouds of red and blue and green, glowing softly in the dark. For thousands of years our dead sun would be wrapped in this gorgeous, radiant veil. The sun's final act would not be violence. It would be one of the most beautiful sights in the cosmos. But that beauty fades. The glowing shell slowly drifts apart and dissipates into space. And what remains at the center, exposed at last, is the sun's dead core. And this core is one of the strangest objects in the universe. It's called a white dwarf. Imagine the entire mass of a star, crushed down into a ball roughly the size of the Earth. It is so dense that a single spoonful of it would weigh as much as a truck. At first it glows fiercely white-hot, but it has no fuel left. It generates no new energy. It is an ember, and like any ember, it will slowly cool. Over billions upon billions of years, it will fade from brilliant white to yellow to red to a cold, dark, silent cinder drifting through space. And the Earth? If our planet survived at all, this is its final home. A dead, frozen, airless rock orbiting the faint, cooling ember of the star that once gave it life. No warmth, no light to speak of, just endless cold and endless dark, circling a dying star at the quiet edge of eternity. And that at last is the true fate of the Earth on the day the sun dies. Not a bang, but a long, slow fade into the cold. But I don't want to leave you there in the dark, because there is one more thing to understand. And it turns this entire story around. Because the sun's death is not only an ending, it is also a beginning. Remember those outer layers the sun gently released into space, the ones that formed that beautiful glowing nebula. They are not empty. They are rich with the elements the sun forged during its long life. Carbon, oxygen, the very building blocks of planets and of life itself. And when the sun scatters those elements across the galaxy, they don't just disappear. They drift through space, mixing into vast clouds of gas and dust. And one day, far in the future, those clouds may collapse to form new stars, new planets, and perhaps on one of those new worlds, new life. The death of our sun will help seed the birth of others. Its atoms will become part of the next generation of the universe. And here's the part that should give you chills. This has already happened. The atoms in your own body, the carbon in your cells, the oxygen you're breathing right now, the iron in your blood, all of it was forged inside stars that lived and died long before our sun was ever born. You are, quite literally, made from the ashes of dead stars. And one day our sun will pass that same gift forward to worlds and beings that do not yet exist. So let's come back, all the way back, from 5 billion years in the future to this very morning, and look at the sun with new eyes. Yes, it will die. Yes, one day it will swell and scorch the earth and fade into a cold ember in the dark. But that day is so unimaginably far away that the entire history of humanity, every empire, every story, every person who has ever lived, is barely a single blink in the life of our star. And by the time that distant ending comes, if our species is wise and lucky and endures, we will be long gone from this single planet. Our descendants, scattered among other stars, might watch the death of our old sun from far away, remembering it as the ancient home their ancestors once called Earth. The sun that rose this morning, the same sun that has warmed every human heart that has ever beaten, will not last forever, but its ending will not be an act of destruction. It will be an act of giving, releasing its light, its atoms, and its story back into the universe that made it. And in that quiet, radiant death, it will do the very thing it has always done. It will give life a chance to begin again.